Large language models are already changing how we write code. But for the world of high-performance computing, good enough isn't nearly enough. Today I'm presenting petscagent Bench, a framework designed to teach AI to speak the language of supercomputers. We are moving beyond generic code generation to target PETSC, the gold standard for scientific simulations in climate, energy, and physics. Our goal is simple: to provide a rigorous, reproducible way to measure if AI can truly handle the complexity of HPC. To understand why this matters, we have to look at the gap between generic coding and HPC. A standard benchmark such as human evil tests only toy problems, like reversing a string, where success is just valid syntax. But in scientific computing, the stakes are critical. If an AI generates code for two-dimensional Navier-Stokes that runs but gives the wrong physics, that isn't just a bug. It's dangerous science. We need a benchmark that understands MPI parallelism, numerical convergence, and memory safety. Following the agent beats paradigm, we built a green-purple battle arena. In this architecture, the purple agent is our candidate model under test. The green agent is the impartial judge that manages the entire lifecycle. By using the A2A protocol and a sandboxed MCP server, the green agent doesn't just look at the code. It compiles and runs it with MPI on MCP servers. But how does the green agent actually think? It uses a 14-step evaluation funnel. First, the code must pass the gates, 4 mandatory checks for compilation, execution, and memory safety. If a gate fails, the score is 0. Next, we measure metrics, objective facts like numerical accuracy and execution time. Finally, we assess quality, subjective traits like solver choice and parallel awareness. Our rule is, if you can measure it objectively, don't use an LLM. We reserve LLM reasoning only for the semantic nuances that static tools can't catch. We test this pipeline against a suite of physics problems. From the stiff chemical kinetics of the Robertson ODE to the complex fluid dynamics of two-dimensional Navier-Stokes, we ensure the agent isn't just regurgitating boilerplate. This diversity allows us to move beyond a single score and perform a true capability analysis, identifying exactly where a model struggles, whether it's boundary conditions or solver configurations. This benchmark is open source, uses UV for fast setup. You can deploy it locally or across distributed machines, and the entire judge's logic is fully configurable via a single YAML file. The benchmark can be run with GitHub Actions workflow. Results are automatically posted on AgentBeats leaderboard to demonstrate the performance of each participating agent. The leaderboard results you see come from the JSON artifacts generated by our agents. This is where the green agent explains its reasoning, providing a granular breakdown of why an agent received their score. In science, if you can't measure it, you can't improve it. With this agentified benchmarking framework, we are finally measuring the path toward reliable, AI-driven scientific discovery.